So today Conrad and I will talk about transforming RTÉ Archive, which has so many different aspects, but it's enabled by main things, which is funding. We have a bit of momentum with the help of our board, RTÉ board, executive board, as well as Commissioner Mion, as we've seen this morning, Jim and Ronan here said opening speeches. Technology is obviously a big enabler for archive transformation, and that's why the digital transformation kind of follows that technological aspect to it. And there is a lot of work done in general on digital transformation of any business, be it our business in archiving or anything else that's transforming in the brave new digital world. Now, for us, these three distinct steps that exist in any digital transformation, we can clearly recognize what they are. So for the digitization is digitizing each individual item, each individual magnetic tape, whether it's video or audio, optical disc or film, that's been individually digitized and organized. Now, I'm also a member of a Preservation Migration Commission of FIAT-IFTA, and we prefer to use term migration because some of these originals are actually digital only, especially on the optical discs, and to be more purist, but anyway, that's what we mean by digitization in our context. And then digitalization is a current ongoing deployment of our media asset management system, which will allow connected exploitation of that content, access to the content, and also assumes a lot of automatic workflows that we're working with our colleagues in technology with. And then obviously digital transformation always assumes transformation of the entire organization on delivering on its vision and mission in the new world of everything being digital and totally new different expectations from our customers, because there is a term of customer journey in digital transformation is how do people actually access your products, services, or content in our case. So one thing that's very interesting in our case, when we talk about these three distinct parts of digital transformation, is that a lot of them are actually happening in parallel, because we're already digitizing in anger. Anya's way over halfway through of audio collection, and Gouws starting on the video. Film is also progressing really well. And in parallel to that, we are deploying our media asset management system, test and development system to begin with, which needs to prove all functionality on a minimum scale. And then once that's proven, we can easily build a full production system on full scale, but whilst keeping the test and development system for future playing with and testing other new things. So I think this kind of really complies with any other digital transformation that exists everywhere else in every other industry that we see today. First thing that we have done, we have very well managed archive in terms of legacy library style archives in all these aspects, but we needed to understand that there's so many pockets of knowledge in different teams, in film, in audio, in video, especially in metadata field. We had separate TV program cataloging and metadata management, and then separate radio program and separate sound library and music cataloging. So once we joined those teams together, we very quickly saw benefits how we can actually deliver way more than the sum of our individual parts. And this was the first step to remove those silos and take a holistic view between all these disciplines. Now, in the team, we also have all the senior archivists in these 6 areas that they have the seniority in that expertise as leaders and supervisors of all those teams that work in those particular areas. And we have seen this working really well. And also we have seen that different progress with different digital transformation, digitization that's ongoing, we have found that there's so many lessons learned, say from audio, that are very applicable on video, and there's common denominators there which are very beneficial for the entire process. Now, next slide on new skills and competencies. Now, sometimes, if you're long enough in this industry, you can feel like dinosaurs here, looking at those robots who are asking us humans, are we not robots when we're doing capture thing? But we were somewhere in between those things, and out of necessity, we have seen these new skills emerging in the team. And it came, some of them by design, so some people did go and do formal project management course and got distinction in it, which we're very proud of. But some things are just, well, here is 200 lines of business requirements, pick ones that we need and discard the ones that we don't. So overnight, our senior archivists and archivists become business analysts, project managers. Development of policy, particularly like the slide from B&G from Sound and Vision earlier about, it sums up how you could actually define development of policy. It's perfectionism versus pragmatism, was it? It was one of those things that's how we really develop our policy with the funding that we have, and obviously we'd want to archive everything to the highest possible standard, but there's some compromises to be made. Metadata modeling, we learned a lot from Mimo today, so there's a lot of common themes, and we're currently doing that in Anger to map, I think, 18 different sources of metadata, 18 different databases, to map them all into the new one. And what's interesting, what we learned in the process of metadata modeling, that unlike workflow design, where there's always that danger to fall into a trap of designing the whole system around the edge case. So we said, let's not do that. Let's keep edge cases as edge cases and deal with them when we need to. Let's focus on the main core aspect of media management workflow. But when it comes to metadata modeling, we do need to actually think of all, and I think you'll agree on us, having done this project, you need to think of a model that can accommodate a name that has 5 first names and 3 last names and things like this. And that's very interesting exercise we're currently going through. Workflow design comes as a given, and scripting, and yet to be developed further in terms of how do we integrate with various QC methods, in file integrity checking, etc., as well as how do we integrate with AI tools that are available. So there is a bit of that light scripting, I call it, required in the team that we'll need, or we'll call on experts when we need them. Quality control in archiving and preservation is a very interesting field, because we spoke about some industry, Gerhard spoke about Baton and some other industry tools that have been around, and VCheck and Serify and all these good things, and they're always very useful especially from conversion from analog to digital, to see how well things have done. But it's interesting how archivist looks at that report versus how a production person looks at that report, because if you work in post-production, you've done your documentary, you finished your audio dub, you finished your video grade, and then you're doing the full tech review, which will give you all the levels to fix, all the legal colors, all the strobing and patterning, etc., that can be fixed before you're going on air. Whereas in archive, when we receive that content, yes, we do want to see if there's any errors found and detected, but we don't really have opportunity to fix it, or even if we do we want to fix it? Do we want to fix very high audio level, or that was artists who intended it to be like that? Or so there's questions like that, but on the QC, on the archiving side and preservation side, we actually found that some things are even more diligent. For example, we have found some inconsistencies with metadata schema delivered from the same digitization vendor or during the same different deliveries. So those are kind of things that we forensically keep checking in order to sign off on any content being, to say, QC passed. And then again, in PMC, we also have this debate about quality control versus quality assurance. Control assumes control, that you can actually do something with it. Or assurance is that, well, we're just checking if this is good, and it is good enough so it can go. There's a lot of debate going on there, but it's all very good and very well informed. Mediated search is a big area of future that we feel, because once technology becomes invisible and transparent, it's actually going to become more about content, we believe. And we already know that we have very fast-pacing production departments in RTÉ, such as news, sports, radio. They need access to something that's happened half an hour ago, and there are relevant pictures, relevant recordings that will support that story being told properly. And for that reason, we have team members embedded in those production teams. So these are archivists who archive content daily, but also help serve the production needs of that particular genre. So that's, I think, going to be even more in demand. So subject matter knowledge on news and current affairs will be always very important to know. How do I quickly find something that happened 6 months ago that become relevant in the news today? Or some sporting event that happened 20 years ago, but there is that sports knowledge that some enthusiasts need to know before they can actually bring it find it quickly. So yes, we hope there will be a lot of self-service in terms of content access and use, but at the same time, there is expertise to be maintained and developed further, and we look forward to that. On the metadata, it's interesting to mention a couple of other things that are not just typical metadata or cataloging parts or technical metadata, but what we're trying to capture, and it's not easy to build bespoke thing, trying to capture editorial or copyright issues that may be relevant to that topic. That's my 12 minutes up. So that's one thing that we need to find the best way of doing, understanding GDPR constraints, but also, especially when it comes to digitization, provenance of that asset. Because, for example, we, being a good library, a good archive, we have several copies of one piece of content. And the one we want to digitize is the original one, or the highest quality one. So that's already important to us to know. And it takes a lot of local knowledge to say, no, that originated on SP, and then we moved it to DG just as a safety copy offsite, etc., etc. So that's important to know, but also to troubleshoot things. So if digitization vendor is doing this en masse, and then serial number of the machine has been recorded and everything, so chances are, if there is one file that came from that machine with some horrendous tears in picture or sound, there may be some others as well. Soft skills is a particularly interesting area where archivists of today need to deal with so many different collaborators and cooperations with vendors, with technologists, with academics, with producers. And there are these soft skills to manage, which again, they kind of tend to be developed naturally. It's a human thing. We just get thrown at the deep end and then sink or swim. And that seems to work where we are able to maintain that sort of heartbeat, communicating with all these places, because we are learning very quickly that we are, in terms of content, being pivotal to a lot of things being built on top of the archive content. Now, this is a very busy slide, and I'm not going to go through every one of those, especially since I've run out of time. But interesting challenge that we have is about new and old workflows. So we have new workflows, old workflows, and the interim. So we actually are running 3 workflows at the moment. So the original workflows with libraries, I found this in the catalog. I believe that this tape contains some interesting content. Here's the library tape. Come back in 5 days or whatever. Then there is the digital version that we're currently testing, which is striving towards self-service. But then there is the intermediary version, which file is just being digitized, but the new system is not ready yet, so it's not ingested yet. So we've come up with a solution that users can still access that copy as well. So this is one of these things that it gets worse before it gets better, but we're living through that pain and still alive. And I think the most important thing is that our users don't feel how busy that is underneath what's going on in order to serve that content. I think this is more of a PMC topic than MMC about content carriers. I think this question has probably come up in any one of your organizations, other than film that we're all planning to keep for a long time. What do we do with magnetic media? Once digitized, do we dispose of it? Do we keep it, or do we keep it somewhere off-site? So that's a topic that some people have strong opinions, and we're trying to be pragmatic. We're saying As soon as we're really, really, really sure that it's all digitized properly, because we only want to do it once, then we can throw it away. But until we know, we won't. And then the multi-platform content, so that's multi-platform content that's emerging, and there's more and more of it. For example, visual radio, I don't know what is it in your organizations, but in ours, it's getting better and better produced. It started off 15 odd years ago with the fly-on-the-wall camera in the radio studio. Now it's with several cameras. Now there is a vision mixer. Now there is. So do we record every single ISO feed of that? Do we just keep the final output? Do we treat it as video production? Do we treat it as radio? Do we treat it as both? So the jury is still out on this. And I want to go into further topics, but I think these are all, having seen the common themes at earlier presentations, I think we all have similar challenges here. And then this is how it all plugs in with technology. So being business analysts, what we do, hand over to technology and say, here are problems, solve it for us, please. But we also do a bit of research and find some ideas how we think this could be solved. So we have 3 major infrastructural projects on the go. One is run by ourselves in the archive, which is digitization and data migration. But the other 2 underlying projects are one media share, which is our MAM system that I mentioned earlier. And the project that's already delivered and that's underpinning all of this is one storage platform. And it's interesting to hear ITMA and it's interesting to hear ORF. Same principles, same approach. How do we ensure longevity of that content, preserve it, safeguard it forever in the brave new digital world? So without further ado, I'll hand you over to Conrad, who will tell you more about this.
Thank you. As Miroslav said, one media share is still in process of being delivered. That's going to be our suite of content management, media asset management tools. But the underlying storage is already delivered. It's already running. So I thought I'd tell you a little bit about that today. We'll start off with some numbers. So when this project arrived, the projected requirement for digital storage was going to be more than 10 times the total storage that technology managed for the whole organization. So we in technology manage all of the technology for the organization. So we're not siloed into production or broadcast, it's everything. And you can see in year 0, that circle represents what we managed at the time. And in year 5, that's what we would have to manage. So it's about 7 petabytes of storage for our digitized archive. And then our born digital archive would start growing at a pace. So in that 5-year period, it would grow by about 2 petabytes. So that gives you about roughly 9 petabytes of storage just for the digitized archive. And the traditional way to protect it would be to duplicate it. So at the time, the plan was to do it on LTO. Would have meant 2 LTO libraries either side of our campus. So that gives you a raw storage of 18 petabytes. Now, as I go through the approach, you're going to have to bear with me. I'm going to give you a little bit of a history lesson in RTÉ first. So, for decades before we had this integrated technology division, the organization actually had 6 separate IT departments. One for TV, one for radio, one for digital. And they approached these things at a system level. So each system would have its own storage, its own compute, built in a neat little silo, and each IT department did their own thing. And basically we ended up in this conceptual diagram that's a mess. At one stage you could name a server vendor and we would have at least 5 generations and almost every model. It's not only a mess, it's also really difficult to maintain. If you know anything about RTÉ, you'll know that money is tight. The capital budget that we get to refresh all of that is about 1/3 of what we need. So unless we find a better way of doing it, we're actually going back every year. So roughly around the same time when this project started, we had adopted a hybrid cloud approach. We decided we were going to embrace the cloud, mainly for compute and for block level storage. And this is the conceptual diagram of our Nebula cloud. As I start naming our clouds, you will notice that the technology team have an obsession with stellar cloud formations. Nebula now provides compute and high-speed storage for about 80% of our systems. So our content management systems, our ERP system, a lot of our production systems, all housed in 2 data centers, opposite sides of the campus. And I really cannot overemphasize how transformative this has been for our organization. So I'll put up that slide to try and show. When it went live, that's what we decommissioned. About 600 physical servers of a variety of ages, and those run in a 2-rack footprint. Technically 4 racks, 2 on either side of the campus for protection, but it's really delivered. It's scalable, it's reliable, it's actually improved the reliability, and it's also helped us meet some of our sustainability requirements. Overnight, we halved our electricity usage. But we had a problem. It's that type of storage, block level storage, it's high speed, it's more suited for databases, virtual servers. It's not really suited for high capacity storage, and definitely not suited for unstructured data, the type of data that we would store, media, audio and video. There was also no way we could scale it. It really does not scale into the petabyte levels. It has some hard limits, and even if you could, it's a file-based storage, so it's got folder structures, and you can imagine managing millions and millions of files in folder structures. But we really didn't want to go the old way with our archive team. So we decided we were going to take the same approach. We were going to take a cloud approach, and we needed high capacity storage to complement our high speed storage. So we started first off by mapping all storage in the organization. This is a high level view of our storage map. And we very quickly realized that while archive was the biggest storage requirement, it's not the only one. And in some cases, some areas had very limited access to storage. So I'll talk through 1 or 2 examples, but in almost every one of those blocks there were issues. The 2 LTO tape libraries were LTO 5s, and they were 10 years old. They were aging. They had to be replaced anyway. A lot of the file storage that hadn't migrated to Nebula were on really old systems. They were power hungry. They were dying. And then you had areas like graphic design or our online teams or even our news playout that had no access beyond the work-in-progress storage. So while they could use Nebula storage for work-in-progress, they had no long-term storage. We found to our horror that our archive team archive on external disks. They keep everything on little external disks in a drawer. So we made the deliberate decision to remove the budget allocated to storage for this archive and bring it over into the whole organization. Because what the analysis revealed was that we could actually fix, and this is the bit I'm actually quite proud of what we have achieved, we could actually fix the entire organization storage issues inside the same cost envelope it would have cost us. And that's purely because of scale. Once you go into that petabyte scale, it's magic how the discounts arrive. So once you buy at that scale, the discounts we get off list prices is amazing. So we've ended up with our Aurora cloud. There's the stellar naming convention. So Aurora is our high capacity storage offering. It sits alongside Nebula. So Nebula provides compute and block level storage, and Aurora will provide high capacity storage. And this is where I actually have to agree with Adam on sustainability once you look at the organizational level. So Aurora provides us with flexible, scalable, and durable storage. The flexibility really comes from that layer that's labeled S3 storage buckets. That is software-defined storage, exactly as he described in his presentation. It's an abstraction layer, so it hides all the complexity underneath. The storage is presented as buckets, so if you've ever worked with AWS, that is the same concept. And all of our systems have buckets of storage allocated to them, but they never really know, and nor should they care beyond maybe contractual reasons or audit reasons, what it is stored on. The on-premises portion, and that's my little typo, I was clearly doing this late at night. The on-premises portion is in 3 data centers. So data center 1, data center 2, data center 3. 2 of those are on campus, and 1 of them is in the opposite side of the city. And I won't go into the details of erasure coding, but thanks to the magic of erasure coding, we can actually afford to lose 1 data center without the loss of any performance or any data, but we don't need duplicate storage. We actually only need 1.5 times the storage instead of twice the storage. So that helps us rein in the cost of storage and helps us continue to meet our sustainability needs. And then on the bucket level, you can apply rules. So you can say, make this bucket immutable, and the system will actually actively resist changing the data. Even if somebody could get under the hood, even if somebody could get down into the bit level and start changing the data, the system will just reverse it. So that's where the durability comes in. The system also, much like Adam described, has slice-level checksums. So as the data is sliced across, it's not a checksum for the file. Each slice has a checksum, so slices can be rebuilt using the erasure codes. And then you can also tick a box to say, copy this, make a copy of this bucket in a public cloud. We have deals with the majority of them. All of that's still seamless to the upstream user. So should all 3 our data centers go away, we can still retrieve from our public cloud while our engineers frantically sweat and fix everything underneath. It also affords us some commercial flexibility. It's all built on commodity hardware. So we can actually mix hardware. We're not tied to a hardware vendor. That's currently HP, but if we decide HP is too expensive, we can go to Dell tomorrow or to IBM, or we can use all 3 of them. So that helps us keep our vendors honest. We're not locked in. They're not going to ratchet up the price. And the fact that we always own a copy of the data helps us keep our public cloud vendors honest. If we ever decide we don't want to deal with AWS anymore, and we now want to go to Azure, we can just ask them to delete the data that they have for us, because we've already sent a copy from our own storage over to Azure. Obviously delete after we're sure it's there, but that kind of sums up the approach we've taken to storage, and I think I'm going to stop there and